Last time, we looked at the various aspects of kinematics of one dimension. Now we break into two-dimensional kinematics, or projectile motion. I'm Emma, and this is It's on the Test. One of the concepts you need to understand in order to do two-dimensional kinematics is the difference between a vector and a scalar. Scalars are amounts that only have magnitude, not direction. For example, speed. So if you're measuring the speed of your car and it was going 20 meters per second, you know how fast it's going, but you don't know where because you don't have a plane. On the other hand, if you were using velocity, which is a vector measurement, and a vector is a measurement with magnitude and direction, you'd have a coordinate plane so you could tell which direction it was traveling in. Many vectors are made up of more than one part. For example, if you were walking to your friend's house on a direct diagonal path, you could figure out how far you were going by first taking the distance you traveled horizontally, then the distance you traveled vertically, and then adding the squares of each number and square rooting them, of course using the Pythagorean theorem. These individual parts of a vector are called vector components, and they can be used for more than just solving for the distance. By using trigonometry, the mathematics field involving the sides and angles of triangles, you can solve for all sorts of things if you have one or two of the components or their angles. Because of this, if you knew the distance you traveled horizontally and the angle you were traveling at, you could use it to solve for the distance you were traveling vertically. This concept is incredibly important for two-dimensional kinematics. I mean, how often do you see a projectile thrown directly horizontally? For pretty much every other time, you'll have to divide the velocity into its part to get any answers. Now we'll start with an example. So if you had a person, and this person was throwing a soccer ball, and we're ignoring air resistance here, and they threw that ball at 20 meters per second at a 30-degree angle. You'd want to figure out the horizontal and vertical velocities. That way you could solve for how far you went, how high you went, and everything. So you can use trigonometry to solve for any of these things. For example, if I wanted to find the horizontal velocity, I would use the horizontal velocity formula, which is the original velocity times the cosine of the angle, so 20 cosine 30. If I wanted to find the vertical velocity, I would use the vertical velocity formula, which is the initial velocity of y is equal to the initial velocity times sine of theta, or the angle. By using these velocities, we can figure out all the different parts of the equation and solve the projectile motion problem. I'm Emma Quinn, and this has been It's on the Test.